Let's try an example where we'd look for the surface integral of y squared plus 2yz ds, where s, the surface, is the first octant portion of 2x plus y plus 2z equals 6. So we can see that that is the equation of a plane. Let's try and sketch a little graph of that plane so that we can see it. We can look for the intercepts by looking for letting different of the variables be 0. So let's say the x-intercept will let y and z be 0. So then we would have 2x equals 6. So then we'd have x equals 3. And if we let y and x be 0, then we'll get 2z equals 6. So z is 3. And then if x and z are 0, then y equals 6. So we've got this portion in this first quadrant for our surface. So then our region R is the projection of that surface down into the xy plane. So we can see R down below. Let's kind of draw it separately here. So we've got the x and the y. So we can see on the y-axis it has an intercept at 6, and on the x-axis it's at 3. And then we connect those with a line, and we've got the portion underneath that plane connects down to where the origin is. So looking for bounds for R, we can see that y starts down at 0 and comes up to this line. So if we look for the equation of that line, we can see it's has a negative slope, and then we can see that it's a slope of negative 2. We go down 6 and over 3. So it'd be negative 2x and then plus the x-intercept of 6, or sorry, the y-intercept of 6. So y goes from 0 to negative 2x plus 6, and then x on the x-axis goes from 0 to 3. So that's going to be our region R. That's going to determine our bounds. Remember, what we're looking for here is we're trying to do the integral over R. We're going to take that f of my f function up here is an f of xyz function, so we're going to do xy and then substitute z with a function of x and y. So we'll end up with something just in terms of x and y, and then we take the square root of 1 plus that function z sub x squared plus z sub y squared. And this will be dA. So first we do, or I guess next what we can do is take this plane and solve it for z. We could have solved it for one of the other variables instead, but then we would have not wanted r in the xy plane. We would have wanted it in one of these other planes, depending on which one we solved it for. So which plane you choose depends on which one you're choosing to be the function versus the variables. So if we do z equals, then it's going to be 6 minus, we would have had 2z equals 6 minus 2x minus y, so that makes z equal to 3 minus x minus y over 2. So then this is our z function that we're talking about up above. So we'll need its two partial derivatives, z sub x and z sub y. The partial derivative with respect to x is just negative 1. The other parts all go to 0. And then for z sub y, we get negative 1/2. So then in our surface integral, we're going to end up seeing the integral of our f function, f of xyz up above was that y squared plus 2yz. So then if we plug in f of x, y, and then z here is that 3 minus x minus y over 2. So we're going to end up with y squared plus 2y times that quantity for z, so 3 minus x minus y over 2. So what we're doing is we're really just looking at the function only in regards to this particular surface. So that function is going to be in here. So we're going to have that y squared plus 2 y all times 3 minus x minus y over 2. then that whole thing is times the square root of 1 plus z sub x, which is -1 squared, plus z sub y, which is -1/2 squared. And then we can look at our bounds we decided on. We did dy first. Y went from 0 to -2x plus 6. And then dx, x went from 0 to 3 was our region R. So now at this point, we just need to work on simplifying this double integral. So we're going to get integral 0 to 3, 0 to -2x plus 6. Simplifying the inside, we're going to get y squared plus 6y minus 2xy minus 2y times y over 2 is just going to end up being y squared. And then we've got all of that times the square root. We've got 1 plus 1 plus a fourth. So we've got 2 plus a fourth, which we can look at as being 8/4 plus a fourth is going to be 9/4 in that square root. So just continuing to clean things up. We've got a y squared minus a y squared. 9/4 in a square root is really just going to be 3/2. So we can distribute that 3/2. So 3/2 times 6 would really end up being 3 times 3, so we'll have 9y. And then 3/2 times a 2 is going to be -3, so we'll have -3xy. dy dx. So then taking the integral with respect to y, we'll end up with 0 to 3. We'll have 9/2 y squared minus 3/2 xy squared, where we'll do that from 0 to -2x plus 6. So plugging in there. When we plug in that negative, we'll need a -2x plus 6 quantity squared. So multiplied by itself, we can do that on the side. So we'll end up with 4x squared. We'll get minus 12x minus another 12x and then plus 36. So we're going to get 4x squared minus 24x plus 36 there. So we've got, let's actually just go ahead and factor that out and then remultiply things through. So we've got 9/2 minus 3/2 x and then times that whole thing. So times 4x squared minus 24x plus 36. So multiplying the 9/2 through, 9/2 times 4 would be 18. So we'll have 18x squared minus 9 times 12 is going to be 100 and, oh golly, let's just grab the calculator. 9 times 12 is 108. So 108x, and then 9 times 18 is 162. And then we'll have minus 3/2 times 4 is really going to be 3 times 2, so minus 6x cubed. And then minus 3 times a negative 12 is going to be plus 36x squared. And then we'll end up with 3 times 18, which is 54. So we'll end up with a negative 54x. Hopefully I haven't messed up any of this arithmetic. If I have, you can fix it. So then put things together. We've got 18 and a 36 gives us 54. X squared. For our x's, we've got 108 and another 54. Be 162, so minus 162x. We've got minus 6x cubed and plus 162. Hopefully we did all that right. So then if we do the integral, so 154 divided by 2 is going to be 27. Oh, except, just kidding, we have to divide it by 3. We can do this. We can do it. So 54 divided by 3 is 18 x cubed, and then we'll have minus 162 divided by 2 is going to be 81 x squared, and then we'll have minus 6 over 4 x to the 4th, and then plus 162x, and we're going to evaluate that from 0 to 3. So 6/4 is 3 halves. So we're going to have 18 times 3 cubed minus 81 times 3 squared minus 3 halves times 3 to the 4th plus 162 times 3, and then minus, plugging in 0 just gives 0 to all of those polynomials. So we'll have 18 times 27 is 486, and then 81 times 9 is 729, and then 3 to the 4th is 81, so times 3 is going to be 243 over 2, and then plus 162 times 3 is 486. So then we've got 486 plus another 486 minus a 729 is 243. So we've got 243 minus 243 over 2 is going to be just times 2 over 2. So we're going to be left with 243 over 2, which is what I was supposed to get, so that's a good thing. So a little bit of algebra and arithmetic to do, but not too bad there. But again, big idea is how to set up this surface integral at the start. Kind of going through all those steps of getting it set up and getting all the pieces where they're supposed to go.